Hey everyone, this is Sonali Mangal, and this is the second episode of Learn, Educate, Discover. On this podcast, we invite people from different professions on each of our episodes, and we ask them a range of questions to try and understand what their job is all about. So, the goal of this podcast is twofold. One, we'd like to expose our listeners to as many different kind of jobs as we can, and two, we'd like to go into as much detail as we can for each of these jobs so that someone listening to the podcast can decide for themselves, does a certain job sound interesting to them, and if yes, how do they go about exploring it further. So, on today's show, our guest is someone who works as a software engineer with Google. His name is Naresh Rapolu, and he works at the Google headquarters in Mountain View, California. Now, I'm sure all of you are familiar with Google. Google is the search company that pretty much all of us use to find any kind of information on the internet. As far as software engineering is concerned, this is one profession that has come under a lot of limelight recently. And this is primarily because of the huge success that technology companies have seen in the recent times. Companies such as Google, Facebook, Uber, Airbnb, all of them are testament to the huge impact that technology is having on our everyday lives. And almost all of them are products of a few software engineers coming together with big dreams, writing code, and the rest, as they say, is history. So, I'm really excited about today's show because I think Naresh will be able to share a lot of very useful insights with us about what this profession is and also what is it that makes software engineers such prized commodities in today's times. So, with that, let's switch over to Naresh. Hey Naresh, how are you? Welcome to the show.
Hi Sonali.
So, are you in the office right now doing this?
Unfortunately, yes.
Hey, I'm so sorry. Were you there because of work or were you sticking around waiting to record this?
The second one mostly, but I mean usually I do stay until like 8:15, so it's my usual timings.
I see. Okay. So tell me something, Naresh. Before I start asking you questions around software engineering, what is your favorite perk at Google? I know Google gives a lot of very, very fun stuff. Yeah.
Uh, I guess since I recently graduated, food and free food is probably the most because I was struggling to cook something for myself, and most often I would eat outside and then struggle with weight gain. So it was this vicious cycle, and thankfully I have now access to free healthy food, and I don't need to waste time on cooking.
That's awesome. So what kind of food do you get? What kind of free food do you get at Google?
So there are a lot of cafes. I think around 25 cafes here in Mountain View, and all of them serve different cuisines. So pick and choose what you want to eat that day for lunch and for dinner, and then that's it. You can just go and eat whatever you want.
Nice. So what did you eat today?
Today I had some Italian pasta, some pizza. Sometimes, yeah, I mean you try not to eat junk, but then sometimes you get tempted and then
I see. I see. Yeah, sounds like a fun place to work. So, could you please start out with telling us a little bit about yourself?
I was born and brought up in Hyderabad. It's in southern part of India,
Mm-hmm.
and I guess most of my life I've been a nerd, if you qualify it that way. I was always more into academics than sports, I guess.
Mm-hmm.
And then I mean, as with most people in my profession, I think I like reading a lot of books. But these days, I'm venturing out, developing my interests in other areas like meditation. I guess there's still somewhat involved, but yeah, I'm trying to become more open and explore more things. But until now, I think I was mostly into books.
Okay, yeah. Uh, what has your career path been like so far?
So let me start from say around high school, I guess. So I was very much interested in math and science, and I think I began writing programs on coding sometime in 11th or 12th standard. And then later on, I pursued my bachelor's in computer science. Actually, I wanted to do core mathematics, but I somehow fell into an engineering school, so I had to combine it with something more engineering. So finally, I ended up with computer science and engineering. And I really liked understanding how computers work, right from software to hardware. And then after 4 years, I felt I need some time to understand this field a bit more, and I was always slightly inclined towards research. Uh, so that led me to pursue a PhD in computer science from Purdue University, and after that, I joined Google, and yeah, here I am, my first full-time job, and I'm having fun.
All right. So, a quick question. So, you said that right after high school, you were interested in mathematics, but then you fell into an engineering school, so you combined the two together. Anything that you think might have helped in developing that initial interest in maths and science?
So actually, I think for me, I had really good teachers uh, for math and science in both high school and middle school, and I think one of the I think they really sparked that interest in me. For example, my math teacher used to be very supportive of me, and then he always felt, I could solve most of the problems myself. So, if you don't mind, I'll just narrate like one of the incidents.
Yes, of course.
And I think that's actually a very instructive incident, I guess. So he always asked me to be ahead of his schedule by one chapter. So suppose if he's doing chapter 11, he always used to say, Naresh, you should go ahead and do chapter 12. So his intention was that I should go ahead, read up the chapter 12 from the textbook, and try to solve the problems myself. So as kids, you kind of take it up as a challenge, and then probably the first time you do it, you're slightly hesitant. But suppose you go ahead and read it, and suppose you do solve some problems in chapter 12 on yourself without anybody's help, you get a lot of it's a lot of fun, and you get that confidence, and from then on you start to solve a lot of problems yourself. You kind of venture out of your academic schedule and stuff. So that's what happened to me. I mean, I think even my science professor always had this my science teacher used to show a lot of experiments. So any chapter in physics was supplemented with an experiment, a physical experiment, and then it kind of ignited a lot of curiosity in me. And so I think science, and I guess so that's I think one reason why science and math felt very natural to me, and so I moved into that profession.
Okay, wow. So, I guess your teachers in school played a big role in developing that initial interest in maths and computers.
Absolutely.
Okay, okay. And then you said that right after graduation, right after your undergrad, you went into research at Purdue. So, what was your research area?
So I was working mostly on large-scale storage systems. Um, I guess to put it in layman terms, these days, like most of these cloud companies like Google, Amazon, and Microsoft are collecting a lot of data from users, and each service now has like hundreds of millions of users, and so you need to have there are these big data centers with hosting like thousands of computers which actually store the data, user data. So basically, the systems which are used to maintain and synchronize the data and make it accessible and available to users, these are pretty complex systems. And in terms of, they're actually software systems, I should say. Um, and there's a lot of science behind how these systems should interact and perform their activities. So it's the whole area of distributed systems, and so I was specifically working on protocols for synchronization among your distributed data centers, and the rest. Let me not go into too much details, but so mostly my research was on large scale storage systems.
Okay. All right. That's. I don't think I understood the full extent of it, but it sounds very, very interesting. Okay. So now that you're at Google, is this a fairly typical background where a lot of software engineers tend to have a bachelor's in computer science and engineering followed by research?
I would not say research is compulsory, but typically most software engineers do have a bachelor or a 3 year or a 4 year degree program in computer science. Research is pretty optional, I would say, because software engineer, even though the term is generic, it really varies what kind of a software engineer you are. So research helps in if you're trying to develop new uh, let's say system software or something new beyond using what exists. So there is this two sides, right? One is trying to develop new novel software, and this, the other side is using existing software components to build an application. So I think research kind of helps you in getting a sense of what has been done and why the current software stack behaves the way it does and how can we improve it. In that respect, I would say research is not compulsory, but yeah, it does help in getting a complete picture of how software, what is software, how does it interact with hardware, how has the whole world of computer science evolved in the past, say, 2-3 decades, and so yeah, it does give you a better picture of things.
I see. Okay. So, what does a software engineer do then? And I think you touched on it a little bit as you tried to answer the question on research, but what does a software engineer really do?
So yeah, I mean, in the generic sense, software engineer writes software, but the word software itself is such a general term because any piece of code you write can be termed as software. So even say previously, most people like say even math researchers would probably write a lot of math on paper and then that's it, right? But these days, even they try to write the code on some simulators in R, and they have their own languages to model the mathematical equations and stuff. So even that could be called a software as long as a computer executes some code. It's a software. So in that sense, what software engineers do is write softwares, but there are a whole stack of different softwares that people build. So there is this one side of software called the system software. System software is software that interacts with low level hardware, let's say either CPUs or embedded systems and all the electronic software or electronic hardware that's out there. So this is called system software, which is very low level. Also, if suppose, as I mentioned, like the part of my research was in trying to build sophisticated or efficient software which can orchestrate and synchronize like hundreds and thousands of computers to make them all work together to get a task done. So that could also be called a system software. The other side of software, which actually is where most of the software engineers lie, is application development, wherein there is a product that needs, let's say, Uber or Microsoft Office or any of these softwares, word editing, document editing softwares. Is basically there is a user, and there are you want some requirements. You have some requirements as to how should the user interact with the system, and then you write a piece of software which plugs in the system software to what the user wants. So this is more application, I would say this is more application software. Even say, let's say designing a web page or building a website is more of application development than core system software. So there are these two, and even in like most companies, you would have engineers working, some of them on system software, some of them on application development or website designing and stuff. And so, as the word goes, most of the work is in engineering a software. Like with any system design, let's say someone has to build a chair, right? And building a chair, like designing and manufacturing a chair involves a lot of processes, and like right from designing the chair to be aesthetically good, it has to be comfortable for the person sitting in. If there is a certain amount of weight that it can tolerate, there's so many aspects to designing, manufacturing something, right? Similarly, even when you're building a software, there are like tons of things that need to go well for that software to function correctly and handle all its user cases. That's where the engineering part of software comes in, making sure that it fits it fits the requirements and it can do its work, even though, suppose, let's say I implemented a software and suppose I leave the company tomorrow and then someone else comes in. Another aspect of software engineering is that new person should be able to understand what I wrote, right? It's essentially, I'm writing it in some language, so the other person should be able to understand it and be able to extend on what I've done. So that's the other that's called code maintenance. That's the other part of software engineering. So I think all of these fall into the general term of software engineer.
I see. No, that's extremely helpful, and I understand that software engineering in itself just is a very, very broad term, because essentially you're writing software. But as you said, there's a lot of different processes that go into it depending on at what level you're operating.
Exactly.
So I think what will be helpful for our listeners is if you could describe the kind of problems that you solve every day. And I'm sure that varies day to day, but what are the kind of problems that you encounter?
Maybe I'll try to take some examples as much as I can instead of being very abstract.
Mm-hmm.
So there are two aspects to. So I would say, let's say if you have a web service, some kind of a web service. Okay, there is, let's say, Google Search is one such web service, right? And it's a software.
I'm sorry, but I think I might interrupt you a couple of times in this podcast just to clarify some terms which you might use, which everyone might not be familiar with. So when you say web service, what does that mean?
So, okay, let's say it's just a website, okay? Just think of a website and how it works as a black box and call it a web service, something which is accessible on the web.
Okay.
So it's some piece of software which is accessible on the web through a website.
Okay.
So let's say, for that matter, as I said, Google Search is a web service.
Mm-hmm.
So it offers something to the users through a web UI.
I understand. Okay.
So if you look at Google Search itself, right? So there is this whole big software that's running somewhere behind that is actually implementing the search functionality. So if you look at that piece of software, there are two basic challenges with that software. One is the system side of it, the fact that that particular web service gets like hundreds of millions of hits every minute, at every hour, from all across the globe. So people expect that service to be always up and running, right? And also the amount of data that processed to actually generate a search result is huge. It has to actually pretty much look at all the documents that are on the internet and then serve the result, right? So every search request, let's say, uses like 1,000 machines or in the back end. These are just approximate numbers, so don't hold me on those numbers. But what I'm saying is, a lot of machines get involved while delivering the result, right? So there is this whole software services which have to always keep these machines running. Even if some machines fail, some other machine should take up its responsibility. Suppose, let's say, the whole of America gets disconnected on the internet somehow. There are some wires which actually run between underneath the oceans, and somehow the internet gets cut off, right? But still, like, someone from India should be able to still use Google Search. For that to happen, the software has to be very robust. It has to what we call as fault tolerant, wherein it should be able to cope with machine failures, data center failures, network failures, and so there is this whole slew of problems in the back end. We call these as back-end services, and these problems are mostly system-level problems. And that's one of the very pressing issues these days for software engineers, because as more people move on to the internet, more part of this world gets connected to internet and more people are coming online, every web service is being used by more people, and so the amount of fault tolerance for that software is proportionately increasing. The other kind of problems that in general softwares try to solve is somehow make life easier. Uber is a very good example of that. I'm not very sure if all the listeners would be familiar with Uber. Or probably Sonali, you can say a bit about Uber. I think.
Yeah, of course. Yeah, so for those of our listeners who are not familiar with Uber, Uber is basically a mobile app where users can simply provide their location and they can call a cab no matter where they are. And we won't go into details of how they actually do it, but it's like on demand cab service, and it's very efficient, great service, and it's all thanks to technology.
Exactly. So that's a good way of summarizing it, I would say. So if you look at it, I think that service existed. The whole concept of a taxi service existed for like centuries, right? I guess even before cars existed, there were horses, and I'm sure there was some sort of taxi service where you could just call some horses because you wanted to move from one place to another, right? So if you look at how software or technology improved that service and made it now accessible on a mobile phone, that is what I would call building software to progress humanity. If I may use that word, it's about changing human interactions in human life and how people go about with their life using software. Google search is another example where you now have access to the whole world's information on a website or even on your phone. So that is where a software engineer tries to identify pain points or places where software can touch humanity and improve life for humans, right? That is the other aspect of software engineering, where you're trying to simulate the world around you and try to somehow make it more easier and solve everyday problems.
Right, right. No, thank you so much. I think that is extremely, extremely insightful. And I think later in the podcast, we will get to why do you think software engineers are in so much demand these days? But we'll get to it once we've covered just the basics of what this profession is all about.
Sure.
So you touched upon, the sort of problems that you might be working with on a regular basis. Can you describe a typical day for us? And, maybe talk a little bit about the kind of activities that you sort of engage in and how much time you spend on each of them.
Maybe I could, give some insight into what I do here on a daily basis. So I'm currently working in the shopping search and shopping express teams. So there are, if you look at shopping in general, there are two kinds of problems that we try to solve. One is making the shopping search or results be more useful to the public. Suppose someone's a teenager and you kind of like the systems kind of understand that the person behind that account or behind that mobile phone is a teenager. Your search result, like the shopping search results, would be typically curated to match the personality who's using the phone, right? So that is the human aspect, as in where we try to understand, okay, as humans, what part of shopping should be simplified, right? That one is, of course, trying to be able to search and choose between many products, and second is trying to find the product with the least cost, or even trying to find the retailer or the merchant who's selling that product at the lowest cost. And say that other team that is also part of this is basically the shopping express team, where let's say you do know what you want to buy, but it's probably somewhere in Costco, which is like 10 miles from your place, and you don't have time to go there and sit in the line and purchase the product. So Google Express is basically you could just buy the product online and it will be shipped to your house on the same day or the next day. So basically these are softwares which where we are trying to understand human needs and trying to build software which solves those problems, right? So a good amount of daily life we spend is spent in meetings where we are just most of the time brainstorming about whatever piece of software we have, how do we improve it so that users find it more useful. Somehow we're trying to improve the usefulness aspect of the software. And of course, the other part of the day is implementing whatever we've thought about, right? So there is this brainstorming session, then we come up with this whole bunch of ideas, and then you start, and someone has to sit down and implement. Unfortunately, software engineers have to do both the things. So they also have to figure out what to do and also actually sit and do it. So that is the doing part. And also there is, as I said, there is also the third aspect, which is just making sure that the actual software you previously written works, and it's actually helping users of current day before actually improving your software. So there is this whole software maintenance that happens, wherein, as I said, as more people are coming onto the web, more people are using the web service, there is more pressure on the software to deliver the results within the given time span. And so for that web service to work, there are like thousands of machines which are somehow talking to each other, somehow doing the work by orchestrating among themselves and then doing the work and actually sending back the results, right? So there is that software maintenance and software just ensuring that things are working the way we want them to work.
Yeah. No, that makes a lot of sense, yeah. So if I were to summarize that you spend your time in figuring out what to do, whether that's on your own or that's in meetings, then B, on actually implementing the stuff that you decide in terms of what needs to get built, and then third, on actually maintaining the software to make sure that it's continuing to deliver, and then maybe you need to fix some things and add some things.
Exactly.
Right. So generally, what are the kind of people that you're working with in terms of their roles and their functions? Are you working with other software engineers, or are you also working with other functions?
Typically, most of them are software engineers. There are also people from other areas of management, operations, research, people who kind of understand the problems, better than software engineers do. So as I said, there is this two aspects to it. One is understanding the market, understanding the external world, and trying to figuring out the problems that actually exist. So sitting inside meeting room won't really do that, as much, right? You have to actually go out, talk to people, or even talk to market, like analyze market segments, and then trying to find what is missing and why is it missing, and are there ways to actually solve those problems. So I think there are all these people, both in operations, they call business operations, with whom we regularly get in touch with, who kind of inform us about their analysis of what the problems are, what products should actually exist, and why do these products solve the aforementioned problems. And at the end of the day, the company also has to make money, right? It's not just about creating software. So there have to be people the marketing people who need to think about how the software can be marketed, how can it actually help the company's bottom line, so that we keep doing the good things.
I see. Okay. That was very helpful, Naresh. Thank you so much. What are your working hours like? I'm sure this varies a lot depending on where you're working and what you're working on. But typically, what are your working hours like?
So I think that's one thing which I really like about the software engineering profession in general, is that all that you need is a laptop, and then it doesn't really matter where you are, and particularly these days with all these video communication software like Skype, and so you don't need to actually be physically present at any place to even talk to your teammates or hold meetings and stuff. So that way, I think in general, the working hours are very flexible for software engineers. We are of course expected to attend meetings. Actually, it really doesn't matter from where you're going to attend those meetings. So typically, I think in my case, I try to be in office between 10 to 5, and then afterwards it really depends. I can either go home and work, or stay back here and work. So yeah, it's pretty flexible, I would say.
I see. Yeah, that's actually a great thing if you have that kind of flexibility. Do you see people, a lot of other software engineers working from home a lot, or how does that work?
Yeah, definitely. I think, let's say you have a family and kids, and you need to go back home to babysit your kid. It's pretty common to see people stay in office for say 6 to 7 hours, and they go back home when they get some chores done, and then probably they come back online to do some of their work again.
I see. I see. Okay. And so, what is the typical career path for someone in this role?
In general, in most of the companies, there are just these levels of software engineers. Basically, everybody is a software engineer, but you just keep changing levels based on the amount of experience you've gained in that product area, and how good you are at building software, and managing people who eventually build software, and leading the product development. So I think, yeah, I mean, to the most extent, it's like just software engineers with different levels, and I guess after that, like in the companies, there's like managers and then VPs, and if everything goes well, one day CEO too. So yeah.
Yeah, okay, sounds good. So, and I'm sure this varies a lot depending on how big or small the company is. Or is it
Exactly.
pretty? Yeah, okay, all right. Okay, so now we'll switch a little bit to understanding. I think by now we have a good idea of what the job is all about. What kind of things do you do? Now we'll go into more about sort of how do you feel about the job. What do you find the most interesting aspects of software engineering to be? And this is of course for you, but what do you find the most interesting?
That's a tricky question, actually. Because I'm just thinking about, should I mention the abstract things that I like, or something, the tangible aspects of it that I like. So
Well, why don't you mention both?
okay, I'll try to. So obviously the tangible part is where you see that the software that you're writing somehow impacts the world. Something in this world changes. Someone's using it, and it's making life easier for someone, right? So that is the tangible aspect, and that's where I think software or products in general, that's creation of products, any sort of products. I think that the eventual goal is to get that happiness, like where you see people using it, and it's improving their lives. The abstract aspect is also, if you're someone who likes actually getting deep down involved in building anything, even if a house is being built, right, let's say, okay, towards the end, yes, it'll look all good, like with all its colors and stuff, but there's a lot of dirty work that needs to be done to actually get the house built, right? Someone has to mix the cement, and like it's all hard work. It's not glossy work, but I think some people enjoy going through that. So I think one of the aspects I do like is where system software, as I said, is it's not at all attractive. You can't even see that software. The impact that it's actually having is it's a very indirect impact, I would say. So somehow building that, like coming up with that new protocol which somehow orchestrates like hundreds of machines. It's a very abstract thing. Very few people understand it. There are two sides to it, basically. One is the user facing aspect, and one is the getting down deep into things. So someone who's coming into this profession should enjoy both, because at some point you'll have to do both. And I think, yeah, it's not, what I'm saying is essentially it's not always, you have to go through a lot of struggle to actually get to a stage where you see the product being used, and actually making an impact in this world. So you have to be ready to go through the tough phase too, of actually implementing and making it work.
I see. Yes, that makes sense. Are there any aspects that you do not like?
So as I said, there is this whole tough phase of actually building the product, right? Making sure it actually works in all possible cases. It handles all the corner cases, you nitty-gritty details of the product. So, these days with all these mobile phones, you build an app and that needs to work across so many different phones, so many different operating systems with various dimensions, various form factors. Another challenge we have in this current world is basically some parts of the world do not have fast broadband access to internet, right? So your service should be able to work, should be implemented in a way that it works for even in remote places where where the internet connectivity is weak. And so there is this whole set of challenges that come across in when you're designing and implementing a software, and it's tough work. I mean, there's no wonder, like, for a single piece of software to be written, like, there are like hundreds of people involved. Software engineers are always companies are still hiring is the reason, because in general building software is complex. It involves a lot of dirty work. Things keep failing all the time. Another thing I think which I don't know if it is a positive or a negative side, but let me put it this way. So suppose, let's say you're building a chair, right? You're manufacturing a chair. There is this whole design phase, and once you finish the design, you somehow manufacture the chair using that design, and somehow you sell it, right? And suppose, let's say, it doesn't get as much demand as you expected. There is this whole, like, you have to again come back to the design phase, so if you look at this life cycle, right, it goes in circles, but the span of each circle is around 1 year, let's say, right? Unfortunately, for software, there is no manufacturing phase. So the day you design, you can actually put it out within a couple of days, as long as it's not a big change. But it also, there is the flip side to it is you also tend to make a lot of mistakes, or you are so, sometimes you could be aggressive and put out a software which is not completely thought through, like all the corner cases have not been thought through. And so because of this short iterating cycle, iteration, we call it iteration period, so it's more like very fast iterations, a lot of problems creep in, a lot of bugs creep into software, and eventually the software kind of so I think that's the aspect of software engineering, is where you also need to consider both the time to put out the software, and also consider the health of the software. Is it being written using correct engineering principles? If it is not, once the software becomes too big, it's difficult to handle. It's difficult to maintain that software and make it keep it running. And so that's the dirty part of software engineering, as I would put it. Making sure it handles all the cases, and it keeps running.
Are there any aspects that you find particularly challenging? And they might be different from the stuff that you just simply do not like.
Yeah, definitely. There are a lot of challenges. It really varies based on the product that the software is trying to actually help. But so let me take the help of example of, say, search or shopping itself, right? So even though the concept of personalization, as in if you know that it's an 18-year-old teenager who's doing those searches, somehow the results have to be curated, so somehow match the interests of teenagers or something like that. So other than the software engineering problems, there is this whole math that comes into the picture of how it's trying to model the person who's using the software, right, and somehow personalize the software to that particular person. And the whole area of machine learning and artificial intelligence is where all of this is generally researched. And most software these days is intelligent. It's not like just storing and retrieving something, but it is also about personalizing, making sure that the software can guess what the user wants, and somehow deliver it to him before even the user actually asks for. So and as I said, most software has this mathematics aspect to it too. And that's where I think currently most of the challenges lie in trying coming up with various models uh, which can simulate or emulate a human, his thinking, his likes, his dislikes. Let's say even suppose it's a music service, right? Apart from just sending you audio, there is this whole aspect of which song should I now play for the user given the environmental conditions he's in, what day of the week is it, what time of the day is it, and what has this user listened to before. So there's this whole aspect of personalization which is very challenging. It involves a lot of mathematics as well as large scale software systems to be able to deliver accurate results.
Right. Yeah. So it just sounds like a very, very complicated problem to solve, I guess. I'm sure software engineers are very super smart people.
These are actually problems which have been around for 30, 40 years. We made a lot of progress, but there is still a long way to go.
Mm-hmm. Okay. So, I'm going to now ask you a few questions from the point of view of someone who might be considering this profession as something that they would like to get into. So, first of all, what kind of person, in your opinion, would really enjoy himself or herself in this job?
So, if you look at writing a piece of software, is very similar to solving a math question, I guess. It's basically problem solving, right? So you know where to go, and you know what are your tools, and you have to reach there. So if you look at like the math problems we used to have in high school, is where you had these bunch of axioms and theorems, and you knew the results, and then there was this question, prove A is equal to B using these theorems and axioms, right? And you would somehow put together these theorems, and you kind of come up with some kind of a logic in your head to how to use these theorems, how to put them together, how to manage variables, and how to write an equation and then solve it to get the final answer. So it's very similar to that. So you have the product, and then you have a whole bunch of tools. There is also the algorithms used to actually solve that problem. And so I think anyone who's inclined a little bit towards logic or problem solving would do really well. Apart from that, I think a good software engineer should also have the tenacity to make sure that whatever logic you've used to solve the problem actually works in all possible cases, right? That's actually a big deal. So if you look at, let's say Google search, so suppose even if you actually come up with some way of writing that software which delivers results, you should now make sure that it actually works for all kinds of search queries, for queries in different languages, even queries which are misspelled. So there is this whole bunch of if-else corner cases, right? And actually most of software engineering is where you probably spend 30% time in trying to come up with the solution and implementing it, and the most of the other time is actually spent in making sure that the implementation works for all possible conditions, and it handles all possible cases. So one has to be somewhat hands-on. You have to have that patience and tenacity to make sure that the software actually works. And keep it running. There will be more issues coming up, and then you have to keep iterating and refining that software. So it's a mixture of both logical skills and the passion to somehow solve human problems using software technologies.
I see.
Did that answer the question?
Yes. No, it answered it very well. So basically, someone who is very detail oriented. Someone who doesn't shy away from going deep into the weeds, someone who has a strong analytical bent of mind and is able to solve problems, and then of course is passionate about solving problems around us and thinking about how you can use software to solve those problems.
Okay. Exactly.
So I know that you touched on the typical background for software engineers, but simply because we are right now in the section about job applicants and what they should be thinking about, could you just talk to it again in terms of if someone is considering getting into this profession, what should they be thinking about in terms of the kinds of education that they should be picking up?
So this is actually something. It's a very good question, and I think my answer to this would be slightly different to what anybody else thinks of software engineers and that profession. I think a good analogy would be, let's say you want to write an English novel. Okay, you have a story in your mind. You somehow want to write a novel. For that, I don't think one needs to get formal education in English, right? I mean, yes, you need to understand a bit about how to form sentences and write, and somehow make sure that grammatically you're almost there. But you don't need to go through a 4 year degree in English literature or English grammar or stuff like that, right? You can write. Probably for the first time you write a novel, probably it'll have a lot of grammatical errors, but there would be some other person who can actually look at that and somehow improve it, and therefore you can keep learning. Similarly, I think just to become a software engineer, at least let's say if you want to say design a website, you don't need to really completely understand how what is software what I'm saying is you don't need to understand the right from the system software aspects. You don't need to understand how completely an operating system works to actually build a website. You don't need to most of we I think there are sufficient number of tools out there which kind of abstract all the nitty gritty details of software, like how that thing would actually work. Most of people who are trying to get into this profession can use those tools and still make do a good job of creating softwares. This is more towards software that is user facing and applications and stuff. I really want to stress on this aspect because I think until recently, even in United States, there was more demand for software engineers than supply, right? So most people kind of even in college they somehow take up other majors because they feel okay, computer science involves you have to understand you have to understand a good amount of math, a good amount of discrete mathematics, logic, and then you have to understand operating hardware, interfacing with hardware. But the thing is, it does sound complicated, but at the end of the day, not every software engineer uses all that he's learned. Okay, so my suggestion is for someone who's just planning to get into this career, don't think of it as I have to master all of it to become a software engineer. Not really. So you can take baby steps. Try to do as much as you can in that curriculum, but you need not be good at all aspects of it. Even if you've got the basics, you can still go about become a good software engineer. You just need to choose that area of software engineering which kind of needs only the skills you have, and not every software engineer does everything.
I see. That's actually very helpful because my next question was going to be, are there any resources that potential job applicants could use? And maybe you could also mention some resources which would be useful for someone to figure out what is if this is my interest area, if these are my skills, then this is what I should be learning.
This is actually something which is a pressing hot topic these days as to how to motivate kids to take up computer science, right? And for that to happen, you need to assemble a set of resources which are accessible, which kind of introduces software engineering or computer science to laymen in an accessible way, right? I think if I recollect correctly, Bill Gates and the Melinda Gates Foundation is heavily involved in trying to create such resources. I think one of their initiatives was coding for everyone, and women in code and stuff like that. Where I think which are a set of websites where they introduce computer science uh, in a way that even layman without a degree in computer science can actually understand and start coding and implement something new and develop something. So I'm kind of I think mixing two people here. One is, if suppose you are in just heading, if you're moving into college and you're trying to choose a major, probably in the first year you can try out these resources where they try to explain computer science in layman terms. And if you then feel comfortable, you can take up the major. Even otherwise, I would recommend people to at least consider computer science as a minor, even if you have interest in some other field, because computer science is not just about being software engineer, but these days you need to have computer skills and understand coding, even if you're doing something completely remote, right? Even if, say, suppose if you're in aerospace engineering, building rockets or something, you need to still model. You have to model all whatever you've designed using a computer, and you have to somehow understand coding. So don't shy away from it. If possible, take up a major in computer science. Even if not, do try computer science as a minor. Even if someone who's already out of college, there are a lot of resources, particularly with YouTube. There are like a lot of on YouTube and Coursera. There are a lot of online courses which, right from CS 101, have access to their videos, and I think there are even websites these days where you can get a tutor for a really low cost. And so the bottom line is, yes, the field of computer science is vast and it's large, but to become a software engineer, you don't need to understand everything.
I see.
You just need to pick and choose what you want to be, and there is only a finite set of skills that you need to acquire for a particular role of software engineer.
I see. Okay. No, this has been extremely helpful, Naresh. I think my last question before we end this show is, what advice would you have for someone who is considering this as a potential career path? Any advice?
To answer this question correctly, I think I should kind of recollect what, during my entire career path, what made me feel uncomfortable, right? So one of the things which any beginner in computer science kind of gets scared of is the amount of interdependencies. Let's say, for a software, if you look at a software, right, it actually runs on a hardware. So to understand why software, the why programming languages are designed the way they are, you kind of have to get a sense of the hardware, how hardware is working, right? Because eventually software has to run on hardware, so there's some dependency there. And then again, to understand how an internet works, right? There are so many components. There is this networks, and then there is this operating systems, and then there's hardware in between. You suddenly start to feel that, oh man, there is so much that I need to understand just to even write a single piece of code, right? But I think it's common. Almost everybody's been through that, and that is an area of debate even among professors, even in the academic setting. Is no one's correctly. We don't yet know how to introduce computer science in the right manner. All right. Do we start with giving them understanding about other dependent aspects before going and teaching programming languages, or you first start to teach language and then talk about dependencies? So yeah, it is still, because computer science itself has been around only for 30 years, maybe 30-40 years. We are still trying to discover a correct way of teaching computer science to kids. And so someone who's just starting off could feel that, there's just too much to understand, and it's all too vague, and it's not being taught correctly. Not many people know how to teach. But my suggestion is keep an open mind. It's a field where the more you do, the more experience you gain, the more you understand about it, rather than someone initially actually teaching you what it is, and then you feeling very like by the end of 4 years you feel, oh, I know everything about computer science, and then you go start to work. It's not that way. You have to just make your hands dirty, and then that's how you kind of understand computer science a bit more. I don't know if I was able to put the right advice out, but I think someone.
Yeah, so I think your advice is basically, it is overwhelming. You will get scared, but don't get scared. or don't let it scare you too much.
Exactly.
Yeah. Okay. All right. Thank you so much, Naresh. I think that is it from my side. Is there anything else that you think that we didn't cover that you would like to add?
I think for anyone still trying to choose their majors, I would definitely say I think computer science is not gonna die anytime soon.
Yeah.
It's how looks like that's how the world is moving towards. That's where it's moving towards.
Yeah.
Lots of online activities, lots of people using technology to in their daily lives. So don't shy away from it. It's a safe bet, definitely safe bet. Um, and it's not just me who's thinking along these lines. There is this huge movement going on in trying to make women join the sciences and mathematics streams, and computer science is one of them. So I have always been a proponent of that thought process. Yeah, if there's someone out there still deciding, I think I hope I made a valid point. I made some valid points in this podcast, and they can use it to make a good decision.
Yeah, definitely. I think this podcast hopefully will convince some people to consider computer science seriously. But thank you so much, Naresh. I think this was incredibly helpful, very insightful. I think you shared a lot of useful tips and resources that will make people both think about what software engineering is, and if they're interested, how can they actually go about exploring it further. So thanks a lot.
Thanks, Sonali. Thanks for having me on this podcast. I hope to hear many other guests on your podcast to actually understand other careers. I think it's a good initiative, and I hope it helps people.
Yeah, me too. Thanks a lot. All right. Take care. Bye. That was Naresh Rapolu, guys, with all his wisdom on what software engineering is all about. I really hope that you enjoyed today's episode and learned something new. My key takeaway from today's episode was that software engineering is clearly going to be a very important profession going forward. If you have any feedback to share with us, or if you would like us to invite people from certain professions, please do share that with us. Our email is learneducatediscover@gmail.com. You can also follow us on Twitter. Our Twitter handle is led_curator. That is led_curator. On our next episode, we will have someone who works as a management consultant with McKinsey and Company. So please stay tuned in. Until then, take care. Have a good one. Bye.